All right, Unit 1 of Physical Science. Unit 1 is all about the nature of science. We're going to start off talking about what is science and how do we compare it to other sciences. We'll talk about the scientific method, which I'm sure is something that you've heard about before. We'll talk about scientific notation, which is a different way to write numbers that are either really big or really small, and do some math problems around that. And then finally, we'll talk about a little bit of measurement, different types of units that we use for measurement, how to take proper measurements, and how that applies to science. And then finally, how to organize all of that measurements into scientific data and how to apply that and present that to other people. So without further ado, let's go ahead and begin. Notes 1, the nature of science. I'm going to go ahead and hide here. So starting off here, let's go ahead and take a look here. Science is best known for which of the following answer choices? A, conducting experiments. B, reliance on tradition alone. C, using only a single reference. Or D, using guesswork at all times. So pause here for a second, kind of think about your answer. You probably already have an answer in mind, but just take a moment, think about it, and see what you come up with. All right, so you should have said that science is best known for conducting experiments. And that's definitely what scientists do. We just conduct experiments all the time so that we get a better appreciation and knowledge of the natural world. If we relied on tradition alone, that is definitely something that we don't do as scientists. If we think about, um, you know, back 200 years ago when people were doing quote unquote medicine, one example of medicine back then was something called bloodletting, which is if someone was sick with, let's say, even a common cold or the flu, a doctor would actually let some of that patient's blood out because they believed that if you let some of the blood out, that person would eventually get better because you're just releasing that sickness out of the sick person. So that was tradition. That was practiced for a really long time. And if I'm not mistaken, I actually believe that that's how George Washington, our first president, that's how he passed away. He had a common cold, and his doctor, quote unquote, led too much bloodletting, and eventually he passed away from lack of blood. C is wrong, using only a single reference, because if you only follow one reference all the time, a lot of times that reference might be wrong. The term fact checking has been something that's been popular more often this decade than in previous decades, where people have more access to the internet and you can do quick fact checking. You can rely on a lot of different sources to get your information so that you're doing proper science and that you're understanding what you're doing. And then finally, D, guesswork at all times. Scientists definitely do not guess. If it's one thing that scientists do is meticulously do experiments over and over and over again to make sure that the results that they are getting are going to be the real results. All right? So the nature of science is observing, studying, and experimenting to find the nature of things. So basically, scientists just want to know, how do things work? They really want to get into the details of all the processes of the natural world and everything that we understand, and just kind of going into real big details about how things work. And so moving forward, you can see that a scientist may perform experiments to find a new aspect of the natural world. They might do experiments to explain a known phenomenon, or they might do experiments to check the results of other experiments, or to test the prediction of current theories. These are all reasons why we would want to do experiments as scientists in the field of science, basically to learn more about the natural world. All right, so when it comes to science, there are actually two main branches of science. The first one being social sciences, and these are going to be sciences that deal with individual and group human behavior. An example of this would be like psychology. Another one would be like sociology, just learning how group human behaviors happen, how humans function as an individual or in a group setting or in a crowd. That's a social science. So it's focusing on the word social. Whereas a natural science is something that is going to understand how nature or the whole universe behaves. So we're basically studying the outside perspective of the outside world, outside of the human mindset. So taking a look at this flow chart, you can see that if we break down natural sciences, Most of the natural sciences can actually be broken down into these three main categories. You've got biological sciences, and biological sciences are going to be the science of living things. We have physical science, which is going to be the science of matter and energy. And finally, we have earth science, which is something that you've probably taken in middle school previously. It's going to be the science of the earth. And further breaking those down, we can kind of see that biological sciences can actually be broken down into many branches. Botany is the study of plants, zoology is the study of animals, and ecology is a study of ecosystem and how plants and animals can their communities can intertwine and rely on one another. And of course, there's many other branches of biological sciences that we can get into. Microbiology is a study of bacteria, for instance, if you don't want to cover plants or animals. In physical science, we actually have two main sciences that we can focus on. And this is actually what we're going to be covering for pretty much the whole duration of the year. In ninth grade science, which we kind of abbreviate and call physical science sometimes, the full name of the course is Fundamentals of Physics and Chemistry, which is basically what physical science is. We're looking at the fundamentals of both physics and of chemistry. So we have physics. Second semester is what we're going to take a look at. But this semester, starting in a couple of weeks, we're going to take a look at chemistry, which is matter and its changes. In physics, we look at forces and energy, so how like an object affects another object when you push or pull it, and how energy can be transferred from one object to another. In chemistry, we're going to be taking a look at matter, which is basically everything that exists. Anything that exists has mass, and it is matter. And see how that changes. How can you change matter from one state to another, or mix it with other types of matters to completely create new matter? And then finally, we have earth science, again, something that might be familiar with you if you've taken this in middle school. Geology is going to be the study of rocks. Meteorology is not the study of meteors, unfortunately. It is the study of weather patterns, which I think is going to be a big growing field. Interesting weather patterns that we've had lately in the summer. And then astronomy is going to be the study of celestial bodies and outer space. Okay. There's many other branches of earth science as well that we can cover, but we're not going to delve into that. The big one that we're going to cover for this year, again, is physical science, the science of matter and energy. Again, first semester is going to be primarily chemistry, and second semester is going to be primarily physics. And not to scare anyone, but we're just doing the fundamentals of these, right? So we're not going into really big chemistry or really big physics. Those will be later down the line in high school. Your junior year, you'll probably take chemistry, and then your senior year, if you choose to do so, you can take physics. So let's take a look at this practice problem really quick. Number 1 says which branch of science is not included in physical science. So let's not take a look at the previous slide. Let's try to use our memory and recall what we just learned about and see which one of these is not included in physical science. Is it A, physics, B, chemistry, C, astronomy, or D, zoology? So just pause here for a minute, kind of read the question through and think it through and see if you come up with an answer. So this question actually has two correct answers. Which two of these branches it has is not included in physical science? Astronomy and zoology are both not included in physical science. And if we want to kind of characterize those even more, astronomy is an earth science, even though it's talking about outer space. And zoology is a biological science. Physics and chemistry are going to be sciences that relate to physical science. Question number 2 states, which science deals most with energy and forces? So is it going to be A, biology, B, physics, C, botany, or D, zoology? So pause here for a second, kind of think about it, recall what we just talked about again. You should have come up with B, physics. Physics is the science that deals energy and forces, and again, that's something that we're going to take a look at really more in depth next semester, starting in January, mid-January. So here's practice problem number 3. And it says this: a student is trying to decide what subject to study. The student is most interested in the way that molecules of living things interact. What should the student study? Should they study botany, geophysics, biology, or biochemistry? So pause here for a moment, try to think through this, and then come up with an answer. So oftentimes when I ask this question throughout the years, a lot of students will answer C, biology, which technically could be one of the correct answers if you really think about it. But if we were talking about living things, but also molecules, so living things relates to mostly biology, and molecules deals mostly with chemistry. So maybe the answer choice D is the better choice here, biochemistry, where we have both molecules and living things being studied at the same time. Moving forward, let's take a look at practice problem number 4. And this is where we're going to have to kind of characterize things and put things in the right spot. So given the following branches of science, classify them as biological, physical, or earth science. Now, before we start characterizing these sciences, I will say that some of these might fall into 2. And if that's the case, let's put them just right in between. So if there's one that falls in biological science and physical science, let's put it right in between the 2. So go ahead, pause here, take a longer time to answer this, and then come back when you're ready. Okay, so these are the answers that you should have gotten. Looking at the biological sciences, these are the ones that characterize into there. Just this is straight from the flowchart that we were looking at before. Botany, again, the study of plants. Ecology, the study of ecosystems. And zoology, the study of animals. Those are all part of the living sciences, of biological sciences. In physical science, we are covering both physics and chemistry this year. And then finally, in earth science, we had astronomy, the study of celestial bodies in outer space, and geology, the study of rocks and minerals. Then we had these 2 other ones, geophysics and biochemistry, to put in here. And I gave you kind of a hint that there were going to be some that you have to put into 2 different spots. So geophysics is probably going to be something that studies a little bit of geology and physics combined. So the study of possibly how rocks move over time. This might be something like someone studying rock slides, or if you want to build a new skyscraper on top of bedrock, you have to understand what type of rock you have underneath, or if the building is going to fall through the rock under it. So geophysics is an important field. And then finally, we have biochemistry, which is going to be a combination of molecules, the chemistry aspect of living things, just like the question that we had before. So biochemistry belongs in both biological sciences and physical sciences. All right, so now we're going to talk a little bit about science and technology and how the 2 kind of combat each other, but also how one leads to the other. Science always leads to better technology, and better technology helps us to find better science. So you could say that there's a very close relation between science and technology. The goal for science is to learn about the natural world. We've talked about this before a few slides ago, and we just have to remember that. The goal is to basically learn more about the natural world. And technology helps us do that. Technology is the application of that knowledge of science to practical use. So we always use science to make better technology, and then we can use better technology to find more science. And so I have a few examples if that seems a little bit confusing. And advances in science and technology will always depend on one another. An example of that is engineers can apply scientific knowledge and methods to design products that people use. So, for example, we can actually kind of understand how our discovery of radio, TV, and GSM waves helped us to develop technologies to use those waves to improve communication. So, a long time ago, within the past 100, 150 years or so, scientists discovered that there were waves that traveled very, very fast, at the speed of light. So, they were able to send data through those waves and be able to communicate much, much faster. Before, if you wanted to communicate with someone across the country, you probably had to send a letter and then someone had to deliver that letter. Communication was very slow. But with the discovery of radio, TV, and GSM waves, we can now communicate much faster. And then finally, with the discovery of the microwaves, we were able to design a microwave oven to cook, and this was made popular in the 1970s especially, but the microwaves were discovered primarily in the 1950s. We started making devices that can help us with experiments. I do have a video later that I want to share about that, about how the development of the microwave and how basically now every single kitchen in the United States has a microwave, or almost every kitchen in the United States has a microwave that people use pretty regularly, at least a couple times a week. So here's another example, liquid crystals, which were very popular back in the early 2000s for a different reason than what we see here. Liquid crystals is basically a matter in a state that has properties between those of liquid and those of solid crystals. And basically it was like it says, it was crystals, but it was kind of like in a liquid state. So if you can kind of imagine that, use your imagination to picture what that might look like on a molecular level. And what we found is that these liquid crystals were sensitive to heat, and different temperatures changed the color of the crystals, or what color was being projected by the crystals. So you can see here on this black film we have someone's handprint, and obviously the spots that are closer to red and orange are going to be much warmer than the spots that are kind of on the blue end. So we were able to kind of manipulate this and say, well, if we have this black film of crystals and then we apply heat to specific regions, we can create certain colors. So how can we use that to our advantage? Well, that actually started the whole flat screen TV phenomenon in the early 2000s. Prior to this, everyone had those like really big box TVs, the CRT TVs. They don't really see anymore. And the first flat screens were actually not as flat as modern televisions. Modern televisions are like maybe an inch or two thick, and these were maybe 3 to 4, probably 5 inches thick, but they were much smaller in thickness compared to the big box TVs that people were used for. So we were able to take a giant film of the liquid crystals like this, and we put it in a screen like this, and then in different spots in the different pixels we apply different temperatures by applying a different voltage, and that actually gives us a specific picture that we can see on the screen. And the LCD TVs became very popular after that, and it kind of sparked this whole thing. Okay, how can we make TVs even smaller and even lighter and use even less energy? So we have liquid crystals to thank for that, but this is how we also apply liquid crystals. We can make a giant film of the liquid crystals, and we can show the temperature distribution on a wall to see, okay, what parts are too hot or what parts are too cold, and so you can show temperature gradients using these liquid crystals. And this can definitely be used later down the line on applications of designing cooling systems. If you have something that needs to be really, really cold to run, then using liquid crystal sheets like this can help you show hot spots. And this is definitely something that's going to be very popular in the future as we design quantum computers and computers that run really, really, really fast. Because one of the biggest challenges that we face right now is, yes, we can kind of make these computers, but there's just so much heat that's being generated that it's not really feasible. So we need to design some kind of cooling system to help with the distribution of heat. And so I've got one more example, and this is kind of an interesting one, but we talked about the microwave oven. And this is talking about the experiments that led up to that. So we're going to watch this video of how did an experiment about heating up hamsters give rise to the modern microwave. So it's kind of bizarre, and it's not as cruel as it might seem on this picture of microwaving a hamster, which definitely is something that we should not do. But we're going to watch this video about how science has led to that with this experiment. So let's go ahead and watch that right now. Okay, so hopefully that video is a little bit entertaining about how we came to the rise of the microwave oven. What we're going to do now is work on this assignment. There's an assignment in Canvas that depicts this exact same flowchart that I'm showing you right now. It should be called the Nature of Science flowchart. And what I would like for you to do is number these keywords 1 through, I don't know how many there are, 2, 4, 6, 8, 10, 11. So 1 through 11. And then write the corresponding number to where you think that keyword belongs. Okay? So again, just to make it really easy on yourself and easy for me to grade, actually, just write down the number next to each one being physics and 11 being earth science, and just write down where you think those things belong. So go ahead and download this worksheet right here where it says Nature of Science Flowchart. You're going to click on this on your iPad. You're going to download this into PDF Expert. And then once you download it into PDF Expert, you're going to notate it and then submit that back into PDF Expert. If you forget how to do that, you can go to the modules in Canvas, and in the very top where it says iPad tutorials, there are two submissions here, or two files rather, on how to download a PDF. There's another one that's on how to annotate and submit from PDF Expert. So these are the two main documents that you can review if you've forgotten how to download a PDF and how to turn something in. So go ahead and do that right now, and that concludes Notes 1 on the nature of science.